Electron deficient compounds. Next study. Electron deficient compound. Electron deficient compound. Okay. The electron deficient compound are those which have insufficient number of electrons, insufficient number of electrons then the number of two electrons bonds, then the number of two electrons bond. Okay, then the number of two electrons bonds are the compound in which there are not enough electrons to form two electron bonds between the atoms are called electrodeficient compounds. Okay, are the compound in which there are not enough electrons, to form two electron bonds to form two electron bonds between the atoms are called electron deficient compound. Electron deficient compound. Example BH3 whole twice, BeCH3 whole twice N, and AlCH3 whole thrice N. etc. are electron deficient compound as they do not consist enough electron to form two electrons bond between the atoms. Electron deficient compound are given more by the element of 13 group, okay, than those of any other group. This is because the atoms is 13 group have the tendency to be 4 covalent but have only 3 valence electron, NH2 and P1, B2H6. B2H6 is an example of electron deficient compound. The structure is given as boron, 1 hydrogen, 2 hydrogen, that is 3 hydrogen, that is 4 hydrogen, 4 hydrogen, that is 5 hydrogen, and that is 6 hydrogen. Okay, number of bonds in B2H6 equal to 8. B2H6 equal to 8. Electrons needed equal to 2 multiply 8 equal to 16. 2 electron per each bond. That is 2 electron per each bond. 2 electron per each bond. Okay, 2 electron per each bond. As boron has 3 volt electron and valence electron, and hydrogen has 1 valence electrons. Boron has 3 valence electron and and hydrogen has one valence electron. Okay, total valence electron in B2H6. Total valence electron in B2H6. Total valence electron in B2H6 is 2 multiply 3 plus 6 multiply 1 equal to 12. Equal to 12. Okay, equal to 12 because 3 valence electrons and 1 valence electrons, that is 6, and 2 multiply 3 plus 6 multiply 1 equal to 12. Thus there are 12 valence electrons sufficient to form 6 bonds, but B2H6 has 8 bonds. As shown in the above structure, as a matter of fact, that is boron, hydrogen. B has 2 electrons, 3 centric. B has 2 electrons, 3 centric bond, and there is 1 electron bond for boron. 1 electron hydrogen, 1 electron boron. Okay, multi-center bonding in electron deficient molecules. Next is a multi-centering bonding in electron deficient molecules. Multi-center bonding in electron deficient molecules. Okay, multi-center bonding in electron multi-centering bonding in electron deficient molecule. Okay, multi-center bonding in electron deficient molecule. Diborate. Okay, B2H6. Diborate is an electron deficient molecule since it does not contain enough electrons to form the 2 electron bond between the atoms. Multi-center bonding in electron deficient molecules can be easily explained by the taking examples of diborane B2H6 molecule. Okay, 2 units of BH3 combine to form B2H6. 2 units of BH3. 2 units of BH3 combine to form B2H6. Each boron has 3 valence electron. Each boron has 3 valence electron. 3 valence electron. And each hydrogen had 1 valence electron. 1 valence electron. Okay, 1 valence electron. Thus there are 12 valence electron. Because 3 to 1 boron has 3 valence electron, but 2 boron present here, so 3 multiplied to 6. Total 6, and 1 hydrogen has 1 valence electron, and 6 hydrogen has 6 valence electron. Then 6 valence electron of boron and 6 valence electron of hydrogen. The sum of both boron and hydrogen valence electron is 12. Okay, thus therefore 12 valence electron present in diborane molecule. Valence electron show valence electron in diborane B2H6. Diborane is 2 multiply 3 plus 6 multiply 1 equal to 12. These 12 valence electrons are sufficient to form 6 bonds, but actually B2H6 has 8 bonds. Okay, these are 12 valence electrons. 12 valence electrons are sufficient to form 6 bonds. 6 bonds. To form 6 bonds, but but actually B2H6 has 8 bonds. Okay. The molecular formula of diborane is B2H6, which is similar to the molecular formula of ethane. Molecular formula of diborane B2H6 equal to molecular formula of ethane C2H6. Hence structure of B2H6 should be similar to C2H6 in order to form the required 7 bonds. The number of valence electron needed is 7, but in B2H6 only 12 such electrons are available. Thus the electrons to the join the molecular formula of diborane, which is similar to the molecular formula of ethane C2H6. Hence structure of diborane should be structure of diborane B2H6 is similar to C2H6 in order to form the required 7 bonds. The number of valence electrons needed is 7, but in B2H6 only 12 such electrons are available. Thus the electron to join 2pH3 unit BH3 are not available between boron atoms. Okay, so 1 boron, 2 boron, that is 1, 2, 3, 4, 5, and 6. 1 hydrogen, that is 1 hydrogen, and that is 1 hydrogen. This is diborane. This is diborane, and ethane has carbon, 1, 2, 3, 4. 1 hydrogen, 2 hydrogen, and this is 3 hydrogen. 1, 2, 3, and that is 4. Okay. Then 1 hydrogen, and that is 1 hydrogen. Okay. This is ethane. After that ionic and coordinate bond structure are proposed for diborane, which are rejected in lack of proof. Okay. On the basis of electron diffraction studies, Hedberg and Schumacher proposed a hydrogen bridge structure, which is confirmed by the Raman spectra and NMR spectra. In bridge type structure, 2 irregular BH4 tetrahedra have one edge common. Thus 2 boron atom and 4 hydrogen atom lie in the plane of paper. These are coplanar, while the 2 remaining H atoms are located centrally above and below the plane in B2H6, and boron is surrounded tetrahedrali by 4 hydrogen. The 2 bridging bonds are 3 centered 2 electrons bond PHB. The bridge structure of diborane, you can see this is boron and this is boron. Okay. And this is hydrogen, and boron, hydrogen, okay? This is 97 degree. This is 97 degree. This is 100 degree, and this is hydrogen. This is hydrogen. This is 122.7 degree, and this is hydrogen. This is hydrogen, and the angle is 1.19 angstrom distance, and this boron to boron distance is boron distance is 1.770 angstrom. Okay, 1.770 angstrom. Okay, head supporting the bridge structure. Head supporting the bridge structure in NMR and Raman spectra. In NMR and Raman spectra, head supporting the bridge structure. Next is fact supporting the bridge structure. Head supporting the bridge structure. Okay. First point. NMR and Raman spectra. NMR and Raman spectra has shown that 4 hydrogen atoms are of one type, while the remaining 2 hydrogen are of a different type. 4 hydrogen atoms are of the one type, and remaining 2 hydrogen atoms of different type. 4 hydrogen of same type which lie in the both ends of the structure are called terminal hydrogen. Terminal hydrogens. The other 2 hydrogen atoms which lie between the boron atom are called bridging hydrogen atom. This is bridging hydrogen atom. Okay, this is also known as bridging hydrogen atoms. Okay, and 4 hydrogen atoms of same type which lie in both the ends of a structure called terminal hydrogen atom. This is also known as terminal hydrogen atom. Terminal hydrogen atom, and this is called bridging hydrogen atom. Okay. Second point. From specific beat data, it is clear that the 100 rotation indicates the 2 bridging hydrogen atoms lie in a plane at right angles to in which 2 boron atoms and 4 terminal atoms lie. Okay. Third point. All the 4 terminal boron hydrogen bonds have the same length. All the four terminal boron hydrogen bonds have same length. Same length is at 1.19 angstrom. Okay. Fourth point. Only 4 hydrogen atoms in B2H6 can be replaced by CH3 methyl. Okay, group. Methyl group, which show the presence of 2 kinds of boron hydrogen atoms Okay, B2H6 plus B2H6 plus BCH3 whole thrice. Okay, पहले माका B2H5CH3 plus B2H4CH3 whole twice plus B2H3CH3 whole thrice plus B2H4 B2H2 CH3 whole 4. This is diborane derivatives. This is diborate. This is diborate derivatives. This shows that only the 4 terminal hydrogen atoms are methylated, hence the 2 bridging hydrogen atoms cannot be methylated. Okay? And next heading is nature of bond. Okay?